Welcome and thank you for joining us today for Leveraging Predictive Analytics in Internal Cloud Implementations webinar. My name is Raleigh Gould and I will be your moderator for today's event. Our featured speakers are Torsten Volk, Research Director at Enterprise Management Associates, and Andrew Hillier, CTO at CiRBA. Torsten has over 10 years managing highly complex IT projects within the virtualization, cloud, and custom software application development realm. His previous work has consisted of helping national and international organizations like the World Bank and Cricket Communications. Andrew has over 20 years of experience in pioneering advanced software solutions, including mission-critical business applications, enterprise systems management technologies, and predictive analytics for virtual and cloud management. He's also a noted expert in the fields of virtualization and cloud computing. And before I hand things over to today's featured speakers, I did want today's audience to know that Torsten and Andrew will be dedicating the last 10 minutes or so of today's webinar to answering your questions. So I do encourage you to log your questions at any time throughout the course of the presentation by using the Q&A functionality located in the right-hand column of your screen. If you're in full slide view, simply look for the floating toolbar and click on the question mark icon, and you can log your questions that way. Also, as an attendee, you will be receiving an email tomorrow from Enterprise Management Associates, which will include the on-demand playback, as well as a PDF of the speaker slides. So be on the lookout for that. And now I'd like to go ahead and turn things over to our first featured speaker, Torsten Volk. Torsten?
Good morning. Good afternoon, everybody. So today, pretty excitingly, we'll talk about how to place and maintain applications in the most efficient and policy-driven and compliant manner. And I'm very happy to have Andrew with me because Andrew is the CTO of the really only company that is exclusively focused on compliance and policy-driven workload placement and capacity planning for virtual, physical, as well as cloud environments. So during this webinar, we'll answer the questions you see on the slide, and you'll find that all of those questions are about intelligent and proactive capacity management. And we'll also talk about more traditional ways of hosting applications, obviously, and how everything fits together. We know that a lot of you are still at the test dev stage for your cloud, but nonetheless, our research has shown that now it is time to think about how to get more out of your private cloud environment. Our goal for today is to make sure that everybody walks away with a very clear and concise understanding of what the considerations are when placing workloads in the private cloud. As Raleigh said, we'll leave enough time for Q&A in the end. So jumping right in, I want to start with the root of this whole challenge and problem, if you will. You can see this is EMA research data from earlier this year, and this data shows that developers, business analysts, line of business staff, they are today's users of cloud resources. And this slide really is there to drive home the incredible impact that business units have on cloud. And especially, when business people, line of business staff, they talk to their kids and they see all those great public cloud services that everybody is using. And they think, wow, can I not have that too? I want something like, like Salesforce, but in a totally different context. Can we build something like this? And they're often frustrated that what enterprise IT gives them comes nowhere near to such cool applications that people want to use. So what business units do is they grab their own developers and they just get going. And often these developers, they make workload placement and capacity management decisions, and that's of course often inefficient, and it can entirely blindside IT operations staff that is concerned with ensuring performance, compliance, and security of all the services in the organization. So these business services that are created through the cloud, like basically any traditionally created business service, they consist of a lot of elements. You can basically think of this as a puzzle where you need to align the individual pieces with the company's business requirements in terms of performance, user experience, reliability, security, and compliance. The problem is the reality in today's private cloud looks a lot different. It much more looks like this, where you have somebody more or less nicely asking IT to please stand up a private cloud as quickly as possible. We often see the request to stand up a private cloud in 30 to 45 days, and IT leadership selects a team to make that happen, and basically the requirement is give me something where my developers can self-service provision pooled resources as quickly as possible. And standing up that type of environment is really not hard at all. We see most cloud firms offer starter kits or whatever they call it for organizations to quickly show initial ROI with their private cloud. The problem is that the moment those resources are available, this private cloud is available with all of its APIs, that's also the moment when things start getting messy. And once the initial euphoria of private cloud is gone, then all these old traditional problems of enterprise IT start to resurface. And this slide actually contains an exclusive preview of still unpublished EMA research. Will be published in mid-July, and the chart shows the true obstacles of private cloud as it comes out of the box, in the 30 to 45-day deployment. And as I said, once this honeymoon period is over and everybody is really happy that they can easily provision infrastructure resources, reality sets in, and security, compliance, capacity planning, high availability are tremendous pain points. And those daily chores to make those things happen have to be governed properly, and the resulting problems can be overwhelming if you don't curb this complexity that all the self-service provisioning is causing. And this is exactly where we see most organizations being right now. They find more and more simple to stand up complex application environments in the cloud. And in a lot of cases, they really underestimate technical and efficiency implications that come with making or deploying those applications in their private or hybrid cloud. And what we need is a clear, consistent, and universally applicable policy framework where you can basically, before anything is deployed, because that's already almost too late when you start deploying workloads and applications, and then afterwards you start worrying about what's going on. But the policy has to already set in before anything is deployed, and you have to take care of all of those elements that you see on this research slide. So policy-based, and this is an interesting slide because this shows what policy-based workload management is and how it can help us all. Policies ensure really that the right kind of resources in terms of servers, storage, network, hypervisors, middleware, and so on, that all of those resources are allocated to the appropriate workloads. And to do this, we need to define characteristics of workloads in terms of what performance requirements do they have, what do they need in terms of security, in terms of compliance with regulations like SOX or HIPAA, what kind of availability requirements do they have? And B, we have to be aware of how your data center infrastructure matches up with all of those characteristics. And what you'll find is that the more densely and the more efficiently you place workloads in your environment, the lower, the higher the cost, obviously, by nature, but also the lower the risk. So if I pack a lot of workloads in a small, in a small number of resources, then the cost is obviously lower. But the cost in terms of violations and problems that I might incur because I didn't make sure that performance and availability is guaranteed can be much higher. So there is this trade-off, and you can see this on this slide where we have our cost curve. The less dense things are, the higher the cost obviously is. And we have our different policies. For example, critical production workloads, they intersect with the cost line much, much higher than non-critical production workloads or dev test workloads. So I can pack dev test workloads on resources that are much more dense, because the concern of violating any policy requirements is generally lower. So instead of over-provisioning based on rules of thumb, which we all often do, or instead of going to finding provisioning requirements in an Excel spreadsheet and all across Word documents and in the brains of a lot of clever people, what we really need is the ability to define policies that then, before the actual placement of the application happens, make a decision what the requirements are, and then determine what should the cost be, what should the density be, what is the trade-off, what's the ideal point, where do I need to place it. And Andrew, I believe that is exactly where you guys come in.
Yes, it is. Thanks, Torsten. And hello, everyone. It's Andrew Hillier here. So definitely we take a very policy-oriented view of this, and this diagram is very good to show the impact of that, because these crossover points where the dotted lines are in your diagram, we would call those control points. And what happens is you really want to stay on that control point to optimize your efficiency, minimize your risk. But most organizations don't really have the ability to stay on that spot. They either go up the green curve or up the red curve. And you either get a lot of cost or a lot of risk in a hurry when you do that. So it's very important to have a way to scientifically control the capacity in this sense. And so, these are all examples of operational policies. And we actually ship 6 policies out of the box. And I'll start by talking about policies, and then I'll go into a bit of a demo of our software. And on the same hardware, using the same hypervisor and the same cloud management platform on top of that, you can actually run environments at completely different specifications depending on what you want them to accomplish. So for example, I won't go through this entire table, but we see some of the things that were in your research. Availability or disaster recovery scenario might vary between different types of environments. If it's a production environment, I might need spare capacity for failures. I don't need that in my pre-prod environments, unless I'm testing failures, of course. It's just a waste of money. You would do compliance. We see very rigorous compliance requirements in, your internet-facing banking service might have very rigorous compliance requirements. Your back office grid that's doing computations all night might not have any kind of separation rules around compliance, or maybe it does. It really depends on the environment. Intuitive to most people, performance requirements vary. That also includes things like we see some environments that are NAS-based versus SAN-based versus SSD-based. Those environments will behave completely differently and have different control points, and by extension, you want different workloads to go into them. You don't want to waste expensive storage on non-critical applications. Even the predictability of the workloads tends to vary. So again, back to these internet-facing production web services, they may carve out very well-known patterns of activity throughout the day. If you have a grid doing mark-to-market or drug simulations, you don't know what it's going to do next. It's almost random. So that impacts the density, it impacts how you plan the capacity. You might have to take a more statistical view of that. And last but not least, and I'll show this a bit in the demo, even the automation strategies vary. So if I decide I want to take action to get onto that sweet spot, that control point, do I need to go through a lot of change management, or can I just issue actions directly? And it's very important to capture that as well, because the goal is to automate. With clouds, of course, automation is key, but it all has to be within reason. You have to abide by all of these factors when you're acting. And Torsten, I find it interesting. You said people talk to their kids to see what they are using as far as cloud applications. This is the slide that your kids just won't understand. This is the overhead of IT for doing things properly. That doesn't go away when you make a cloud. It doesn't magically disappear. It needs to be abided by. And it really captures, it's also a convergence of, in your new research there, a lot of those elements all converge on one, they have to be under one policy because you can't treat them separately. We want to make sure that we are running at the right utilization levels while still having the right spare capacity and still meeting our separation rules. It all has to be done at once. So that's, that's a bit of a convergence in the policy world that we're seeing that's all driven by policy. So let me go ahead and share my desktop, and I'll bring up a bit of a product demonstration and talk about how we use policy to control virtual and cloud environments. And I hope everyone can see the screen up with the colorful spectrum and all the dots. Let me give a quick explanation of what you're looking at. This is what we call our control console, and it's designed to be pointed at a steady state running environment, virtual or cloud environment. And what it does is gives you a visualization of all the moving parts inside that environment. So if you go from the top down, and you can see it's labeled here, the top band in the diagram, in the spectrum, are the clusters. So we have 5, in this case, this is a VMware environment, so 5 VMware clusters. There's 29 hosts within those clusters. That's the middle tier of the diagram. And at the bottom tier are the VMs or the guests, and there's 241 guests running on those hosts in those environments. And they're color-coded so that one environment carries through the different tiers of the diagram. Now we're rendering them on a spectrum, this red, green, yellow spectrum, with the red representing whether you are running at a high risk. You don't have enough capacity to do the work that you're doing. You're under-provisioned. The yellow zone is the waste zone. You're wasting money. You have way too much capacity or too many resources assigned to those components, and they're not utilizing them. And the green zone is where you want to be. That's within the optimal planning goalposts based on policy. And each environment might have a different policy. So what puts production into the policy might be when its servers are running at a certain utilization level and there's a certain amount of work happening, and we decide that it's not safe to go any further, whereas opposed to dev test, which might have a completely different policy that puts it into the green. Now let me drill in on one of these clusters in this case. These can also be VLANs, or in the IBM Power world, it can be LPM groups, whatever logical grouping you want. Let's just isolate one of them and talk about what this is saying exactly. So here we're saying that this is a shared services environment, and you see that there's the number 0.75 after the name. That's what we call the efficiency index. And that's telling us the ratio of how much capacity we need to how much we actually have. And you can think of it this way. It's like taking all the workloads and all their patterns of activity throughout the day or throughout the week or the month or quarter and playing Tetris with those workloads against the available capacity. And we're saying, what we're saying in this case is that we have 8 hosts in this environment, but you can safely do all the work on 6 and still meet all of your policy obligations. So that gives us an efficiency of 0.75. And 1.0 is the center line. 1.0 is the perfect alignment of supply and demand. It means you have the exact right amount of work for the capacity or the right amount of capacity for the work, depending on how you look at it. The far right-hand side would mean that we are basically empty. We have way too much capacity. And the red means that we don't have enough capacity to do the work that we're doing. Now, it doesn't mean that the VMs are crashing. Back to your risk curves, you have to go pretty far up that curve for things to fail miserably. But it might mean that I don't have enough capacity for certain DR or HA scenarios, or to meet my separation rules, or to meet my peak season. You might be okay today, but you won't be okay for long, or in certain types of failures. That's what the red zone tends to mean. So here we're getting a pretty good view of our efficiency. And in this case, this environment has spare capacity. A quarter of the environment is spare. And that's based on policy. And let me show policy just for a minute to give you an idea of what's under the covers here. I went through that table in some detail. This is what an actual policy looks like. And in fact, I have a pull down, and I can choose which policy is governing this environment. Again, it might be a critical production environment, dev test. This one's running a production IT policy. And so that dictates a whole lot of different criteria of how we manage this environment. Now again, I won't go through all of these areas, but just to give you an idea, let's start at the bottom and start with the speeds and feeds, what will be traditional capacity-oriented metrics. In this environment, I don't want to see my VMs go above or below a certain band of activity. In this case, I don't want to see the CPU go above 65% sustained based on 30 days of history. So I have upper and lower bounds on my guests, I/O rates, memory, ballooning activity. Again, the sky's the limit as far as the coverage of that from a numeric perspective. I also have controls on the host level utilization. I don't want to see my hosts go above or below certain operational parameters. And again, that includes memory and active memory, I/O. So we're going to scrutinize all the details of operation here and make sure that this environment stays balanced and within spec for this type of environment. And again, this is an 85, for example, is the upper limit on CPU. That might be 50% in a critical production environment. It might be 100% in dev test. So you can see there's variation even in just these stats between different environments. Now, if I go up the list, we start to get into some different types of characteristics. Some of them are less traditional. So what's my overcommit ratio? we see customers using different overcommit ratios, usually around a 5 or 6 to 1 overcommit for production environments, maybe as low as 4 to 1, maybe around 8 or 10 to 1 in dev test. So this is how I allocate out resources, not just utilization, but the resource allocations, how aggressive or conservative I am with that. What are the business hours? Am I optimizing to just weekdays or 24/7? And you can even, I'll open the advanced settings here, because you can even say, I only want to tune my environment for the 90th percentile activity. And it's a bit of an advanced topic, but that's useful for cloud bursting, because we might say, we're going to size our internal environment to a certain level of activity, and then we're going to find other capacity for the rest. So I can even control through the control policy whether we're sizing our internal environments to the complete activity or just a portion of it. We have HA policies. Do I keep servers spare? Do I use them or not? So you can see we're starting to get into more and more abstract things that cover more and more of those items, Torsten, in your research. This isn't just a capacity question. There's also an availability question. There's safety margins, separation rules. Because if I keep going up, I can even get into more abstract things, like do I separate out security zones? Do I keep customer data off certain parts of the infrastructure? Do I have business separation rules? Do I have technical rules that force things together or push them apart? Do I want IIS members to go to different physical boxes? The idea here is that we get a very, very detailed level of control covering all those areas we talked about, and it all is in one policy. So it's all converged in this one control specification for this environment. Because when I manage these environments, I can't do these things in isolation. And as you mentioned, it can't be tribal knowledge or in smart people's heads. It has to be down in the system so we can scientifically control it through algorithms. So enough policy. I'll get out of there for a second and just show what this is saying based on policy. So we can still meet all of those policy obligations with 3/4 of our infrastructure. So the distance from the center line is visualization of the spare capacity. But the problem is, if I go down to the host level, even though I have spare capacity, I have hosts that are running hot. And so if I select one of those hosts and open the bottom area, I can first of all see what it is. This is a DL380. I can see what it's doing. I can see all the host level metrics. Again, all the ones I mentioned, I/O rates, all that stuff. And we have, in this case, 2 resource policy violations. This server is using too much memory. We're not comfortable with the level of memory utilization, and we've allocated out too much memory. So we are breaking policy. This server is doing too much. It's too much memory utilization, and so it's gone off into the red. Going beside it has a different problem. It's using too much sustained CPU within business hours. So again, this is uncomfortably high. This might not be performing well at all. And so even though I have too much capacity, I have these issues. And the problem here is because at the far right, I have a server that isn't carrying its weight. In the last 30 or 90 days, whatever the policy says, it hasn't even hit the low water mark for utilization. And this is a real environment. So this is a visualization of an imbalance in workload placements. I have plenty of capacity, but the VMs or the instances are in the wrong places. And I need to fix that because I need to get everything back into the green. And that's the whole paradigm, is get everything into the green. Now, at the bottom tier, there's a different problem again. Again, the capacity can be quite complex in these virtual cloud environments. At the bottom level, even though I have too much capacity, I haven't given enough to these VMs. So this one is starved for memory. Its active memory's gone too high. And this other one just to the right of it is using too much CPU. Now, again, this is where policy is very important, Torsten, because if this were a batch job, this might be perfectly fine. That's the way it's supposed to operate. So the whole spectrum is not a utilization chart. It's a policy violation chart. And we can tag at the VM or the app level and say, this whole application has different operational parameters. Or this VM, it's allowed to run at the roof. That's what it does. That's normal for it. So that's, again, even further underscoring the importance of policy. It's very, very sophisticated how you define right and wrong in one of these environments. And in this case, these ones in the red are out of the comfort zone. They need more resources. The bottom right zone is what we call the reclaim zone. These are components, in this case VMs, that over a certain operational history, usually 90 days is typical, it hasn't even used a fraction of its resources. So we've allocated too much to this VM, and we need to take it back. But we have to be very careful how we take it back because it might get busy once a quarter. So again, that's where policy comes in. We want to make sure that we watch it long enough to make a proper judgment of when we can reclaim resources. And cloud with self-service portals oftentimes get a lot of dots in the bottom right because users, if they have the ability to ask for their own capacity, they will generally ask for too much. And like I say, it's not because they're greedy. It might be, but the more kind explanation is because they don't know what they need. And so the only prudent thing to do is to ask for too much. And that's perfectly fine in our view because we will watch that and over time and then reclaim resources as we see fit once we've seen enough operational history. So that gets us to the actions. So we're actually going to generate very specific actions to fix this problem. And for that one in the yellow, we're saying take a CPU away. And the policy says send that to a service desk. So in this environment, we need to go through change management to actually change the size of a VM. If I click on the one on the left, we're saying add a CPU to that one. And again, open a change ticket. And that should help get all the dots on the bottom into the green, but that won't fix the middle tier. And you kind of get a hint at that because you see at the bottom there's also a movement recommendation. So we can reallocate resources all we want, but that won't stop these servers from being overutilized. For that, we have to move the VMs around. And so we're also getting a very detailed placement plan of how to reshuffle these VMs to balance out not just CPU and memory, but again, I/O, context switching, whatever metrics you're trying to balance, we will balance all of those out to make sure this environment runs very well. And in fact, we do a visualization of what that will look like. If you take all the actions that we're recommending here, we can visualize that in the UI, and you can see this concentration of dots at the middle tier is very good. That means that we're getting equitable use of resources across our physical assets. And at the bottom tier, we see that we don't have any critical misallocations of resources at the VM level anymore. We still have some in the yellow, and that's because VMs that stay down here too long are usually doing nothing. So I can't take away the last CPU of a VM. If it's been running there and it's been resized and it's still in the yellow, you can probably just turn it off. That's a good indication of deadwood. So the main thing is we've managed to clean up, or what we call defrag, this capacity. So it's all balanced out, it's running well, it's going to run far better and be less volatile than before. And now we can put more work into this environment to get it to the center line. And in this environment, for example, if we have a quarter of our capacity spare, we can put a third that much work in it again. So you can actually, from a mathematical perspective, put 33% more work in this environment to get it to the center line. But you can't do it when it looks like this. When you have this mess, it's already not behaving properly. And we see a stall point around 0.5 to 0.7 efficiency where people stop putting workloads into the environments because they're already not behaving very well. So the last thing I'll show, Torsten, is just if I go back to this entire environment now, hopefully what we can see is this is a small data center. It's a Boston data center. We have spare capacity in all of the clusters in this environment. Only one of them is actually well into the green. Yet we have imbalances in 4 of the 5, and we have misallocations in 4 of the 5. And the only reason we don't in that brown one is because there's almost nothing in it. So we have this is an actual environment. This is a capacity situation we see a lot of times when you look at a running environment where if there hasn't been a scientific control of capacity, we have all these issues. We are under and over provisioned at the same time. We are low efficiency, high risk. And what we want to do is turn that around and say, we want to fix this up and fill the environments up to the center line so that we're high efficiency, low risk. And again, we want to do it in a policy compliant way, so that we can make sure that we're meeting all of the obligations that you outlined in that research, the unreleased research you mentioned. So back over to you, Torsten.
Thanks, Andrew. So specifically, and I like you use the term scientific, because specifically in a cloud context that I just talked about, where everybody is just provisioning their environment based on, things they see, based on things they think they need, and based on this whole newfound cloud freedom. Out of a sudden, there are so many dots that are out of those goalposts that, Andrew, you talked about. Everybody might be super happy about what's going on with cloud and how agile I am and how scalable I am, but if I do not have something like this, like CiRBA, then I'm going to have a significant efficiency issue. And what I really like about what you've shown, Andrew, is that this is all in one place, and that all the policies, your policy manager or editor, is centralized across the entire data center. So I can basically go into one place and I can see, okay, here is my batch server, my batch scheduling server, and here's, what is attached to that server in terms of requirements, compliance, security, all of those things. And here are my web servers, here are my test environments, and, I don't have to chase down people and Excel sheets and, public shares and Dropbox accounts where all this stuff might be stored. So another great aspect that I thought is that this is an ongoing monitoring thing that you are showing, where you visualize. You can come in, you visualize what's going on in the environment, and everybody knows configuration drift, and developers change machines and do all kinds of things to the environment. And just having a central dashboard like that, where you can just go and see what's going on and see, wow, you know, there's those servers, they're still, even though I've taken resources away from them, they're still over provisioned. So what's going on with those? You know, see who they belong to and ask if they can go, if I can get rid of them. So another interesting area that we found repeatedly in our research this year, and I think this money burger symbolizes those charts, specifically the bottom chart, pretty well. Another really important area is storage. And you see the top left chart shows the importance of SSD and flash storage for cloud deployment. And what's interesting is our random sample for the study had about half of the companies with stage 1 of their private cloud implemented, and the other half had a later release of their private cloud implemented. And we asked both parts of the sample, obviously the same question: how mission critical is SSD and flash storage? And you can see that blue piece of the cake is drastically larger with later stage in cloud environments. So 47% of later stage cloud environments said that SSD and flash storage is critical versus 28% of initial cloud deployment. And another interesting observation that's actually even more impactful in terms of economics is the incredible waste that's going on because of storage management that's just not intelligent. You know, we just ask companies, hey, have you bought more storage when actually what you needed was more intelligent management of your existing storage so that you get more performance out of what you already have? And in 25% of the cases for large organizations with 10,000 and more employees, the answer was, yes, we just throw money at the storage problem and make it go away. So that basically means what you get for this additional money is that you do not have to think about what you do with the storage. But if you more intelligently managed your storage, you'd really not have to buy a new SAN, and you could save 25% of your storage budget for large companies. It is a little bit less for smaller companies, obviously. And Andrew, here are two questions for you. One is, do you help customers? We've seen the host, we've seen VMs, we've seen clusters on this dashboard, but do you also help with storage? And another one is, we've seen you analyzing, basically coming into a data center and analyzing the status quo. But do you also help looking into the future of what's going on in the data center? Let me just make you presenter for this.
Sure. Yeah. So absolutely, and I would you know, attribute a lot of these things to the inability to predict demand, especially in clouds. We see that it becomes extremely difficult to figure out what's coming down the pipe and how I deal with it. And from a storage perspective, you know, your money burger is spot on. You're going to spend a lot of money on storage and perhaps on expensive storage. So, you know, I found that interesting stat you have around the later stage focus on storage. We tend to see early clouds are maybe NAS-based or based on kind of one-size-fits-all storage, but later on, organizations start to differentiate maybe with a SAN-based environment or a Fusion IO-based environment, and you start to make tiered levels of storage, which comes a bit later, but then it starts to bring up, you know, the whole fit for purpose. You know, policy then needs to be used to route workloads into the right kind of environment, so you're not wasting money. You're not putting, you know, dev test workloads on your SSDs and then putting critical workloads on your NAS. So the tiering is important, the policy is important, but also just forecasting demand. So let me show you a feature. Let me go a little further in this demo and show you something interesting. I'm going to close up the environment selector and open up the timeline. So everything I've shown up till now in the demo has been for right now using historical data. So let's take as much history as you have and figure out exactly how to optimize this environment to get everything into the green. Now we can also go back and forth in time, and going back shows you the actuals, day-on-day actuals, and forward shows us the forecast, the predicted picture of 30, 60, 90 days in the future, as you see on this timeline. And when I click there, if you watch the spectrum closely, you'll see two things happen. you'll see the dots sliding around. Those are the trends in the data. That's things getting busier or less busy. And you will hopefully see some dots flying in from the left-hand side, and I think the WebEx is interfering with the animation, so let me just make absolutely sure that that's not appearing. But we're tracking the trends. We're doing two things that are very important. One is consistent with traditional capacity management is, are my workloads getting 10% busier or getting less busy as time goes on? But we're also tracking what's due to come into the environment. And if I open this left-hand side, you'll see we have a bunch of inbound bookings. So there are actually a lot of new dots in this diagram because in the next 30 days, I'm forecasting a whole bunch of new activity in this environment. I have a consolidation wave coming in. I have 8 SAP modules that are due to be deployed in the next 30 days, and they are being rendered on this spectrum. And in fact, now you can see that shared services is actually perfectly full within 30 days. So we're forecasting this environment to be spot on in the next 30 days because of this inbound activity. And I like to use hotel analogies for all this type of stuff. If I go and check into a hotel, if you look at trends versus bookings, hotels, clouds are a lot like hotels. And the good example of that is if I go and check into a hotel, they don't really care if I'm growing an inch taller every year or even every month. They just care when I'm showing up and when I'm leaving, and they'll allocate a room to me. That's all like a cloud. If I'm staying at the hotel for 5 years, they might care if I'm growing and having a family and I need a bigger room at some point. But for the short-term stuff, the capacity is dominated by the bookings. So here we have a bunch of inbound application activity, and in this case, consolidation waves, and we now see that shared services is perfectly full. If I go forward to 60 days, you'll see shared services marches off into the red zone. And that's because I actually have even more activity. I have a second consolidation wave coming in, and I don't have space for it. So again, sorry, the hotel's full. I've overbooked, I've oversubscribed that capacity. I have 8 servers. It's forecasting that I will need 9. So I can do several things here. I can say, you know what, let's go into my booking system and reject this inbound activity. Sorry, you can't come here. Go to production 2. There's plenty of space there. So we can reroute that workload somewhere else. I can also say, you know what, we have 60 days. Let's deal with this a different way. Let me go and add a new, I don't know, IBM 3850 or DL380 into this environment on the 26th of the month into my shared services environment. And if I click submit, a new square will fly into the middle part of this diagram, and we should balance out the capacity again. So I can reject demands. I can add supply. I can even do this. I can even say, you know what, let's go and find all the components of this environment that are supporting a certain business service. So I can do logical overlays. Let's find by criticality, by line of business. Here, let's find a non-critical app. Let's take automated testing. And I can see all the infrastructure supporting my automated testing application. And you can see it's across a couple or 3 different clusters. The main part is in that shared services cluster. So I can actually grab these and say, what if I put them somewhere else? What if I move them to my internal dev cloud or prod cloud or high density cloud? Or what if I move them to IBM SCE Plus or Savis or whatever the external provider is? And if I do that, it's going to run a full analysis of those workloads, the patterns of activity against the catalogs of these remote external clouds, and give me a full report on how and if and how they map into that external capacity. And the upshot is, if I go ahead and do that, if I say, that's good, let's get those out of here, when I go forward in time, I will actually see that app come out of the environment and go off to the right into my outbound side. So I've now booked out the capacity and rebalanced my supply and demand again. I've now removed some of the work from this environment, so I'm back on center for this environment. So you can see this is a completely predictive view of inbound and outbound supply and demand, and that's really the root of all inefficiency is the inability to figure out what's going to happen down the road and buying way too much. Just like if you don't have a hotel reservation system for your hotel, you're going to have to build twice as many hotel rooms because you have no idea who's going to show up. Now, that's the predictive part. Now, what I wanted to get to, Torsten, was to show you storage, because I've been showing the compute picture here, but I can actually turn on a storage center. So I've gone back to today, and if I turn on storage center, here I can see my data stores in this case. And if I select them and pop up on the bottom, I can see there are 8 data stores. I can see their provision space, their used space, the number of VMs that are attached to them. And I can even graphically see that. So I can say, this data store on the left, what VMs are actually using it. And so I can look at the logical linkage between my compute and my storage. Now, this is useful, obviously, to visualize this and to see how things map together, but the real power comes when I go forward in time again, because we also book the storage. So when those new demands come flying in, they also have their storage requirements and usage associated with them. And you see now in 30 days, I am forecasting that I will saturate one of my data stores. And so we find this is a pretty big topic in our customers because it's expensive and it's an inexact science, and running out of storage is a problem, or buying too much storage is a problem. So we can actually visualize that right on the same spectrum as the capacity, the server compute capacity, I should say. We can also visualize the storage capacity. And with that, Torsten, I will pass it back over to you.
Thanks, Andrew. Yeah, it's very exciting to see that storage is a topic in capacity planning, because I don't have research slides for this in this deck, but storage is one of the biggest pain points for any private cloud deployment and for a lot of other kinds of deployments, such as desktop virtualization, for example. Then there's another big topic, and I want to do this relatively quickly so to give everybody a chance to ask questions in the end. But multi-hypervisor strategies. We can see on this slide, and this is a very recent slide, only a couple months old, 82% of organizations are currently pursuing multi-hypervisor strategies. 63% somewhat, 19% drastically, and only 18% not at all. Interestingly, when we look at the different hypervisors across workloads, you can see the different workloads at the bottom there: databases, big data, email, desktop, dev, test. You see that the gap between the different hypervisor platforms closes dramatically. And if we move to the following chart, we can see one more thing, and that is that cloud is a catalyst basically for multi-hypervisor strategies. Cloud really makes it easier to manage multiple hypervisors in the data center. So it's basically an additional abstraction layer that can connect to more than just one hypervisor. And when we take a quick look at why organizations adopt different hypervisors, we see performance, licensing costs, features, and maintenance costs right at the top of that list. And it's really interesting to see that 47% of organizations believe that there are drastic or significant performance differences between different hypervisor brands. And that leads us to the key challenge of this multi-hypervisor strategy, which very much goes in line with what Andrew was showing regarding the policies. The question is, how do I rationally and consistently determine which hypervisor I should use? I mean, even if my beliefs about performance differences and license costs and features, they might not be right. You know, that might just be my belief, then other hypervisors might have caught up, but there still needs to be a central underlying policy that guides what my developers, what my IT operations staff places on what kind and what brand of hypervisor. And hand in hand with that goes what I call a software challenge for cloud, because just like with the hypervisor, we have so many considerations when we spread software out over different cloud resources. We might actually lose track of where we are putting our software, or where our cloud platform, our software that manages the cloud, places the software. You can see this list of bullet points, and there's a lot more considerations than just those were just 4 examples. There's so many ways of placing software in the cloud, and there's as many issues that can result in terms of being entirely under-licensed or buying too many licenses. It's a very similar problem than buying too much hardware or too much, storage that Andrew showed when he demonstrated a new storage sensor in CiRBA. And Andrew, I think CiRBA is also able to help with hypervisor targeting and the software license management. If you can show the audience very briefly, we really don't have much time left, but if you can show very briefly how CiRBA helps with software and hypervisor targeting, that would be great.
Yeah, I can, and I will be very brief. I notice we're getting near the top of the hour. So let me show 2 things very quickly. I'm going to scoot over to this Toronto environment, we've been looking at Boston, but I'm going to go over Toronto because it's actually running another add-on module, which is a software licensing optimization module. And you see the policy looks similar to the other ones, but it has this extra area saying, while I'm optimizing my VM placements, do it in a way that minimizes the operating system cost in this case. So it's going to detect Windows versus Linux and use that as a criteria when it's defragging the environment. This is the front office environment. The back office environment is optimizing Oracle. So it has a bunch of hosts and a bunch of Oracle databases. And when I optimize that, you won't see much difference on the spectrum. It's still getting everything in the green. But what it's doing is it's putting all the, in this case, the Windows license components on these physical hosts and all the Oracle databases on these two. And I can actually pull up a report that tells me the savings. So if I, let me just pull the PDF very quickly and show that in this environment, we get a complete report telling us that, you know, in the original case, we had 57 Windows VMs that were running on 10 hosts. We can safely put them on 6 and not license 4 physical servers for Windows. And then go through the policy and all the details of that plan. And in the back office environment, we had Oracle VMs on all 5 servers, or sorry, running on 4 of the 5 servers, or 5 databases on 4 physical boxes. We can fit them on 2 and not license 2 of those for Oracle. So there's a very significant savings, even just around maintenance in doing that. And again, it's just part of the policy, just being a little more clever about how we place the workloads will save a lot of software costs as well. The other thing I'll show, you mentioned multi-hypervisor. You see if I click on this New York environment and pull it up, it looks similar to the other ones. It's got colorful dots everywhere. This is actually an IBM Power environment. Let me just turn off actions here. So this is, if I pull up the bottom here and click on one of these hosts, this one is actually a P780 with 48 CPUs. It's got a bunch of shared processor pools. I won't go into the details of the Power platform, but we see quite a bit of Unix out there. It is the right tool for the job for certain jobs. So it's really all about scientifically deciding what goes where. And we have policies that dictate, you know, this environment can handle certain levels of I/O and is suitable for certain types of workloads from a qualitative and quantitative perspective. They should go here. Other ones maybe go into my KVM environment. And there are differences in the way these hypervisors behave. Even the policy in this case is much more complex because, you know, again, I have shared processor pools. I have entitlement management. I'm just going very quickly here. But in the IBM Power platform, there are even more control points to control the capacity. So it's useful for certain types of workloads. And the idea is you want the right, you want to align the requirements of the workload with the capabilities of the infrastructure is the best way to think of it. And you want to do that in a scientific way. And then have one way to manage all the capacity across all your different environments, just to different specifications. So that's software optimization and cross-platform. Very quickly, back to you.
Thanks, Andrew. Yeah, it's interesting to see how you handle software and hypervisors just like you handle network storage and compute resources. Because at the end of the day, all of those things can be costly. And specifically when we look at the marketplace for private cloud, and we've published a radar report on private cloud earlier this year where you can see a comparison of all of those different vendors and what their capabilities are in capacity planning and management and workload placement. And what came out was almost shocking, and the fact was that none of those vendors really did any of what Andrew was showing today. So it is really, even though a lot of vendors, and I said before, 50% of our vendors in that study sample had later releases of cloud, but customers are currently, in our experience, at a point where they start feeling the pain, but they don't exactly know what they can do about this pain. So if we go to this next chart, which is also unpublished research, we have confirmed that capacity management and operations analytics are tremendous obstacles for companies to reach optimal cloud ROI. And this is, and you know, we talk so much about OpenStack, and that's why I know Andrew has prepared how this works for OpenStack, because if OpenStack doesn't have any policy, OpenStack out of the box, let me put it that way, doesn't have any policies behind it when it places workloads. It's a very simple algorithm that does really not optimize what you place where in any way, and Andrew will just show briefly what CiRBA does to connect to OpenStack and to add those capabilities that you've just seen to the OpenStack environment.
Yeah, absolutely, Torsten. We're seeing a lot of interest in OpenStack. It may be early as far as production deployments, but there's certainly a big groundswell behind it. And if you look at what it consists of, sorry, let me go back one build here. I think people assume it does more than it really does. It's a very powerful solution for giving end users a request console and provisioning capacity when they ask for it. And when somebody requests that, it has a built-in scheduling algorithm, Nova Scheduler, which is very, I won't say it's not very sophisticated, and it's not really the fault of OpenStack. It doesn't have the utilization data or the policy to make very informed decisions. So it uses a chance algorithm or variance on that to figure out where to put things. So very basic placement, because it's not really its intended purpose. It's designed to turn things on, create VMs, start them, stop them, and delete them when the user is done. We sit off to the side of that with the control console I have been showing and gather detailed metrics from the environment, analyze it using policy in a very deep way, and generate actions to optimize that environment. So it's a very complementary relationship. We will fix up the environment, constantly tune it, reallocate resources to make sure it stays optimal. Now, that's a useful way to operate, but last week we actually announced an API that interacts with what we call a workload router that allows products or solutions like OpenStack to talk to us directly to get placement recommendations. So instead of using that random algorithm, it can now initiate an initial placement request through us. We will analyze it and say, here, we're going to look at all the environments and say, here's exactly where it goes at the environment level and the host level. So that should go on the East Coast x86 environment, put it on host number 7. So we're going to give a very, very intelligent placement of that. And also, this whole API supports bookings. So if I picture, if you will, a world where not only can users ask for capacity right now, but they can actually put a date on the request and say, I don't need it right now, I need it next week or next month. We have a big project going off July 15th. I just want to make sure you have enough space for my app. So we can actually support that as well, and in the predictive timelines, secure that capacity, lock it, and give back a booking ID. And so if you think about it, it turns any cloud request console into a hotel reservation system just by adding some predictive analytics behind the scenes. So the advantage is we get the ability to be very intelligent up front where we put things. We have the ability to reserve capacity, and then on the back end, we can constantly optimize the density and minimize the risk. And we've actually done a mock-up of OpenStack. So we released the API last week, and what we're currently working on is a reference implementation in OpenStack. So this is kind of the out-of-the-box Horizon UI. This is it with CiRBA behind the scenes. It's just a mock-up where we can see that, first of all, it's making much more intelligent placement decisions, which the end users may not even know is happening. They might be perfectly happy just with whatever they're getting. But we also see that we now have the ability to not just launch, but book capacity. And in addition to the normal launch, the additional parameters, I can provide when I need it. And now we see a booking in the list as well. So this is a very, very elegant extension of virtually any cloud platform, not just OpenStack, by saying that we're going to add analytics behind the scenes. So you don't just need to ask for things right now. You can ask for them for when you need them. And at the heart of this really is if I were to boil all this down, we're seeing an interesting trend in self-service. And I put together a definition of what we see people defining self-service as. And it's giving end users the ability to request capacity whenever they want it through some portal or system, and then immediately provisioning that capacity for them to make use of. And what I'm finding is that I'm going to challenge this word immediately. Is that really part of the definition? Because if I go in on the internet to book a hotel room, I don't book it for tonight. I book it for whenever I need it. But it's still self-service. And it's a very important point. So, if I'm going to Disney World next month, I don't want to drive down and get a hotel room right now and keep it for a month. I just want you to give me a booking ID for when I need it. So really, the underlying problem we're seeing here is that there's two different use cases getting mixed together. Casual use or unplanned use of capacity, and enterprise or planned use of capacity. And to give the analogy to hotels, if I'm on a road trip driving from New York to California, I generally don't book my hotels. I don't really know where I'm going to be. I stop wherever I am, and I get a hotel or a motel. And those motels are designed to be used that way. They're used, you get them overnight, and then you short-term stay, and that's the way they operate. And it's really kind of an unplanned use case. If I'm going on a business trip, if I'm attending a conference or visiting a customer, I always book my hotel. Always, always, always. This is intuitive to most people. You would not go there and take your chances, go to New York and hope you get a hotel room. It's just not good practice. And this really captures the essence of the different use cases we're finding, that in our customers, they tend to build internal clouds focusing on the left-hand use case, when really the right-hand use case might even be the more important one. When you have lines of business groups that are wanting to make use of this capacity, but in the way with their business processes, the way they do things, which is generally planned, just giving them a self-service console that gives them VMs immediately doesn't always give them what they need. So I want to reiterate, both of these are self-service. One is just a very sophisticated version of that, and what we're finding is that's even more relevant to enterprises as they embark on internal cloud. Once they get past that initial iteration on cloud, they realize that they need to have something that's much more in line with the way they do work internally. And again, that in enterprise case, that means planning and booking capacity.
Thanks, Andrew. And that doesn't only work for. Can you advance the slide? Or that doesn't only work for. Thank you. For OpenStack, you know, any of the other clouds have the APIs that can make this happen. But the problem, and that's based on our research, the problem is always the same, and it is always the problem of what am I going to do once I do more with my cloud than throwing it as an Amazon EC2 equivalent to my developers? What do I do with my cloud once I start being serious about putting production workloads on it? So you can see, and this is also an interesting slide, it's also unpublished research that will be published in a couple of weeks. I'm giving most of this away for free, apparently. But you can see the market share, CloudStack, OpenStack, 15% at this early point in time. It is definitely a growing technology. And when you look at IBM Smart Cloud, it's also heavily based on OpenStack. So the overall number of OpenStack deployments is actually even higher than those 15% indicate. But none of those cloud platforms in that entire list has the capabilities to do policy-driven workload placement. So all in all, now we are pretty much out of time, and we probably talked over our Q&A. So to just wrap up in 2 sentences, cloud is not a magic potion. Cloud is the self-service provisioning of pooled resources. And once I'm able to do that, I have to allow and facilitate proactive planning in my environment so that I can do what Andrew showed with the hotel booking. You know, I have an SAP project next year. I have a service that are going away, maybe a mainframe that is going away, something else that gets added, and my standard response of just buying a little bit more hardware and you know, making sure that and hoping that everything is fine is getting more and more expensive. So we have to be more intelligent about this. And as I said, our research clearly shows that this is where customers currently feel the pain, why about 80% of cloud deployments are not getting the ROI that they initially anticipated. Raleigh.
Thank you, Torsten. If you can just advance it to the final slide. We are a little bit over the top of the hour, but I did want to point out some additional resources to our audience. And let's just take one question. For those of you who asked questions and we weren't able to get to them, I will go ahead and forward those on for you so those can get answered. Andrew, one question for you that came in is, when optimizing software licenses, does it have to be done at the time of contract renewal?
It doesn't have to be. That's obviously a good time to do it. We see that as a driver when people are renewing, but it can be done anytime. So on renewal, we see 2 different scenarios. One is if you are at a renewal and you want to try and reduce your usage, then you can do that compression or that defrag, as we call it, to get a better one. A lot of times we see a big advantage just in not increasing your license spend. So if you're expecting that on every renewal you're going to have to bump up by so much like you do every other renewal, this can kind of halt that growth. So we see that as a very effective way of achieving the ROI. But as I also alluded to, just the maintenance on some of the software is so astronomically expensive that doing it anytime makes sense from a maintenance perspective. So we've seen, I won't name any names, but expensive, say, database products out there where just using this technique to defrag the servers that are running that and get it to a smaller footprint saves a huge amount just in maintenance. So anytime is a good time to do it. The renewals are a good time to drive reduction in the overall kind of CapEx side of it, but there's also an OpEx side of it that you can reduce anytime just by killing off some of the maintenance costs.
Great, good to know, Andrew. Thank you. And I wanted to thank our audience for joining us today. As I mentioned at the start of the webinar, you will be receiving an email from Enterprise Management Associates tomorrow. It's going to include all the resources listed on this slide, as well as the on-demand playback in case you missed anything, and a PDF of the speaker slides. Thanks again for joining us, and enjoy the rest of your day.